Hi everyone. I hope to, of course, to joining me on this lesson 17.3, which is talking about the graphing linear non-proportional relationships using slope and the y-intercept. I know it's long title, guys, but of course we will specify each part of it, which is that what we mean by linear, what we mean by non-proportional, and the slope-intercept form will work together, guys, as a warm-up to remind you. Linear, guys, means we have a straight line. Then the relationship is a straight line. This means linear. Non-linear, guys, means not a straight line. Non-linear means not a straight line. The relationship not a straight line. So, like a linear is a straight line relationship. And non-proportional, we have, guys, two kinds of relationships, which is proportional and non-proportional. Proportional, guys, when the line crossing the origin, then we name this, of course, this equation as a proportional relationship, while non-proportional when the line not crossing the origin, could be on this position, could be on this position, no problem, guys, but must not crossing the origin. The slope-intercept form, you know that there is a relationship in a slope-intercept form between the slope and the y-intercept, which is y equals mx plus b. And you know that m represent the slope, while b represent the y-intercept. So let's start, guys, with the first example, which is y equals half x minus 3. So you know that the slope-intercept form represented by this formula, y equal mx plus b. M represent the slope and the b y-intercept. From this relationship, guys, we can notice that the slope, which is m, represented by 1 over 2 as a slope, while the y-intercept, guys, is negative 3 as a y-intercept. So now I can recognize, guys, the slope and the y-intercept. What about if we need to graph this equation? Of course, you must take to your consideration the label of the points, of course, and the arrows as well, and the axis, guys, the x-axis and the y-axis as well, and the relationship. So let's start by the b, which is negative 3. On the y-axis, guys, you know that b is the intersection with the y-axis, the line crossing the y-axis. We name it what? We name it the y-intercept. So it is negative 3. Negative 3 will not be on the positive side, will be on the negative side. So 1 and 2 and negative 3. This is the first point, which is negative 3. Now the slope, you know, the slope, it is rise over run. So rise, we have it here, guys, as 1. Rise is 1. So I will move, of course, on the y-axis 1 step upward. Then run, it is 2. So I will move it 2 steps, of course, on the right side, sorry. This is another point. We can graph a line, of course, with 2 points, but no problem. We can also take another point. And you can rise 1 step. This is rise 1. And then run, it is 2. So 1 and 2. This is another point. So we can now graph the line. So this is the line, guys. We can graph it. It is represented by y equals half x minus 3. This is the first example. Now let's start with example number 2. Of course, y equal to 3x minus 2. You know that the slope, which is m, is the coefficient of x, which is 3. And the y-intercept represented by, of course, negative 2. So now on the coordinate plane, the same, of course, take to your consideration the points, of course, the arrows, the x-axis and the y-axis, and now we can, of course, plot the points. So the y-intercept is minus 2, so it is 1 and 2 on the negative side. And then, of course, the 3, you know the 3, we can put it over 1, which is represented by rise over run. So the rise is a 3, so I'll move it 3 steps upward, so 1, this is 2, and this is a 3. Then the run is 1, so I'll move, of course, 1 step on the right side. This is another point. So we have 2 points. We can graph the line but of course, if you need more points, so we'll take them in 3 steps. So 1, 2, and 3. Then, of course, run. It is 1 step to the right, and then we can graph the line, which is, of course, passing through the points.